go. Starting recording, talking about how to get a code to repeat something, one line of code or a bunch of lines of code, get them to repeat more than once, okay? So we want to take one line of code and repeat it. We're going to call it a counted loop. If we wanted to put this hello world on the screen 20 times, we could do that. Let's see how you do it. You write the word for, and in most coding languages, a counted loop is known also as a for loop, counted loop, or a for loop. Okay? Then in brackets, it will close the brackets for you. It's much like an if statement in that regard, except this bracket needs three things. The first thing it needs is for you to make a variable that will be able to count up or down. So I'm going to declare a variable. Most for loops, when you first start out, I just always give it the variable name I. I stands for index. It will be useful later on when we start making variables that can hold more than one thing. The second, so then you put a semicolon, okay? The second thing you put in this bracket is a condition that needs to be met for the loop to run. So I'm going to put the condition I is less than 10. Or what did I say? I wanted 20 times, right? So run it as long as I is less than 20. And then you put your code in the curly brackets what you want it to run. Okay? Now, let's run this and see if it goes. It's missing something. It's missing this semicolon here. Is it going to run? Look what it's doing. It's not stopping. Okay? Do you see my cursor down here?
Why though?
The reason why is because I is always 0. And it's checking is I'll run this line of code as long as I is less than 20. And it always is less than 20. So the third thing that we have to put in is an increment, which makes I change. And you could either go I equals I plus 1, and that'll make it increase by 1. Or often the shortcut you see is I plus plus. I plus plus will also make I go up by 1. Okay? So now it should run 20 times and then stop, because I will eventually get to 21. Hello? There we go. It only took 5.4 seconds to run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's hard to tell because I got my font so big, but there you go. It is running 20 times, hopefully. Now, is there a way to check? Yes, there is a way to check. Because I made this variable I go from 0 to theoretically 19. As soon as it gets past 20, it will stop. So I am going to put down I. Now, how do I get it to right beside hello world? I'm going to put I like that without an end line. I could do it that way. I like to put it all in the same cout statement. Here's something a lot of people forgot. When you're mixing and matching different variable types and you want to output them on the screen, you have to separate them by the double arrows. So hopefully that will put the row number that I'm on and then the word hello. Look at that, it did. It wrote the numbers 0, 1, 2, 3. Now you don't have to start at 0. You can start at anything you want. Okay, I could start at 1 and I could make it equal 20 and it would say hello world 20 times. Okay, you could see that it's actually keeping track of it with that variable, so that's going to be handy later on. It's going to save us a lot of code. Let's run it 200,000 times or 2 million times or however big an integer can get. You can see how fast the computer is running, right? It's already at 5,000. The only thing really slowing it down is having to print it on the screen. But you can see how fast these computers can count. Okay? It's already counted to 20, 30,000. Now, if I don't put anything on the screen, watch how fast it runs. It'll run through this 2 million times or 20 million times or whatever. Let's see how long it takes to run 20 million times. It took less than a second to run 20 million times. Okay? That's fast. These computers are very fast. Okay?
Why can't it display all of it at once? Like, what is it like?
The monitor is slow, right? The reaction of the computer sending things to the monitor is slower. Okay, that's kind of the bottleneck in computers, but it doesn't need to be fast. Your eyes only can see about 30, like can detect motion. Anything over 30 frames per second, you just see it as like fluid motion, right? So the monitors, typical monitors, only have to run, you know, within from 30 to 200 times per second, and you won't even notice any difference. Okay? Let's get it to print out. Let's get it to print out just numbers without an end line here. I'm going to print out this. I'm going to just go 200 million. See what it'll do. Whoa! It's like a matrix screen. Cool, eh? I made my font bigger. Okay. It's already at 40,000. Yeah. 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 Laurent, what's up, buddy?
I just want to ask something. Like, can you stop doing this?
Oh yeah, okay.
Shouldn't it have said hello world 21 times? Because, like, that's 1 and then plus 20.
Yes. Yeah, that's right. I think we kind of missed it though, because my font was so big that we didn't see the first one. Yeah. But you're right, actually. I should get rid of this line altogether. Okay, so that is how you take advantage of a computer's ability to compute. One way to do it is to put code in loops, okay? And that's going to be useful for us later on. Let's say we want to, here's a good idea. Let's add up all the numbers from 1 to 100,000 and see what it adds up to, okay? So I'll make an integer called total, like that. And I'm going to start it at 0. If I don't start it at 0, remember it'll start with junk in it, and that's not what I want. So I'm going to count up all the numbers from 1 to 100,000. Let me just write in 100,000 here, okay. Like that. And I am going to, each time I go through the loop, make total increase by itself plus I, because I is going to be 1. Then the next time I is going to add 2 to it, so it'll be at 3. Then I is going to add 3 to that, it'll be at 6. Then it's going to add 4, it'll be at 10. So on and so forth. I'll add 5, it'll be at 15. Let's see what the first 100,000 numbers add up to be. Cout total. Okay, this is there is no other way you could get a computer to add up the numbers 1 through 100,000. I've done it in one line of code, basically. The answer is 705,082,704. Okay, just gotta trust that the computer knows how to do it, and it took less than a second for it to figure it out. That's pretty insane that this computer can add up 100,000 numbers in less than a second. It's very quick. Okay. Can I do other things? Could I go up by tens? You could definitely go up by tens. You just say I plus equals 10. And then I will go up by 10. That's a trick. Can you go down? If I go I minus minus, my program will never stop. It's because, yeah, I will always be less than 100,000. See the condition here where it's saying stop the loop if I is greater than 100,000? Well, if I take away I, like if I keep going, it'll just get negative, but it'll never get greater than 10,000. Yes, Laurent.
Why do you have the equal in there? Like, it says I equal, no, the second one.
This one?
Yeah.
Oh, you could put less than as well. I wanted to include the 100,000. If you just put less than, it'll count to 999,999, and then it'll stop. Like, let me show you with the debugger how it works, okay? Hopefully my debugger works. So I'm going to start at 1. I'm actually going to stop my program right here. Okay. So there's a way to watch your variables as you go through your code one step at a time. Hopefully we can see that. Okay, so I'm going to go to my variables. I'm going to look right now. I wish there was a way to zoom this in more, but okay. Let's have a look here and see if it'll let us zoom it in. Hello? There we go. Okay. So right now total is 0. I is garbage because it hasn't done the line where it sets it to 1 yet. Okay. So what button steps through the next line of code? Is there like a special button that does that? Let me just check here. Next line, F7. Okay, great. So if I hit if I go to the next line of code, did I lose my watches variable here? Great. I is now 1, okay? And total is going to add 1 to it, and now total is 1. Now look, my cursor has gone back to the top of the for loop. It's just going to loop. That's why it's called the loop. It just loops around and around until it's finished. So now I is 2 because it's gone through the loop once. Just move this up maybe a touch more. Okay. Oh no, I didn't want to do that. It like sucked it up into the thing. Okay. Let's do it like that. Okay, great. Okay, so the next step now, the line it's on is where it's going to add total to itself plus the letter I. So it should add 2 to my total, and my total should be 3. And that's right. Now I is 2, so it should add, it should go through the loop again, and I is now 3. It's going to add 3 to my total, and now I'm at 6. Now I is 4. Notice how it's just looping through this little bit of code. It's waiting till it catches an instance where I is ever greater than 10. Or where, yeah, it's only running as long as I is less than 10. So as soon as I gets to 10, my program will stop. That loop will stop. So now I have I is 5. I'm going to add that to my total. Now I'm at 15. I is now 6. I'm going to add that to my total. I'm at 21. I is now 7. I'm adding that to my total. I'm now going to be at 28. I is now 8. Add that, 36. I is now 9. Add that. I'm at 45. Here's where the loop stops. It just stopped. Okay? Why did it stop? Because it changed I to 10, but the loop says don't run it if it's not less than 10. Okay? So that's the condition that makes it stop. And total is 45. It's going to write that to the screen. It's now on the return 0 button, which is going to make the program quit. And now I'm done. I stepped through all my code, and I should be able to see 45 on the screen. Okay. So that's a nice feature, too, if you really want to know what's going on. Debug it. And watch the variables. That can be useful. I don't think it's very useful for beginners, because there's a lot going on to begin with, but that is how you get a computer to loop through code. Okay? So check out Lab 7.